Hi everyone. So, quick video on surds. From the description, we know that a surd is otherwise known as a radical. A surd is a number that is an irrational number that can't be broken down any further. So, what does an irrational mean? An irrational number mean? It means it can't be written as a fraction. Okay. So, let's take some examples. Root 20 is not a surd because, well, root 20 by itself is not a surd because this can be broken down. Do you see? This can be broken down into root 4. So 20 is made up of 4 times 5, isn't it? And from our indices laws then, right, this is the same as 4 times 5 all to the power of a half, which is the same as 4 to the half times 5 to the half. I think a lot of people don't really take the time to understand these elementary operations. Even people right up into uni, don't really see it in this way. But 4 to the half is obviously 2, and root 5 is a prime number, and that can't be broken down. So it's 2 root 5. So actually root 5 is the surd, because root 5 cannot be broken down any further. It's not a square number, okay? Root 20 can be broken down into a non-root form, okay? So 2 root 5, and root 5 is your surd, because root 5 is an irrational number, and an irrational number means it can't be written as a fraction, and the decimals just go on forever and never repeat themselves. So in your calculator, you're going to get a long number if you put in root 5, but that's not actually what root 5 is. Root 5 is, it goes on forever. All those decimals go on forever, and they always follow a different pattern. So you'll never be able to quantify it. I mean, a third, the decimals go on forever, 3, 3, 3, 3, 3, right? But it's a predictable pattern, and therefore it can be written as a fraction. Okay, so we understand now what a surd is. Simplifying surds then, we're just going to break it down in whatever fashion you see fit, because there's several ways you could do it. If you're not really sure how you can split it, well, if you see an even number, you could write that as root 2 root 45, so you could always take out a factor of 2 every time. Do you see? So that would be root 2, and root 45 would be, well, 5 sticks out, doesn't it? 5 times 9. So, but remember, it's root 5 times root 9, okay? And root 2, root 5, root 9 is the same as 3, isn't it? Square root of 3. So actually, the root 2 and the root 5, if we're trying to put this in the form of a root b, root 2 can't be broken down and root 5 can't be broken down. So that's the same as root 10, do you see? So that's 3 lots of root 10. So you could have looked at root 90 as square root of 9, square root of 10, and seen that as 3 root 10, and then looked at root 10 and that gone, well, that only splits into 2 and 5, and they're both prime, so I can't write this in that form. Root 10 is enough. Root 10 has been broken down. That is in surd form. Okay, it can't be, it's never going to bring out any terms in there which aren't surds. Okay, root 6 over root 3, how do we deal with that? Again, if we see that as the multiples of 6, which is root 2 and root 3, if we did root 1 and root 6 would be in the same position, all over root 3, we can see that root 3 over root 3 cancels, and you're just left with root 2. Root 32 over root 2, again, you could look at that as root 4 times root 8, or you could look at it like root 2 times root 16. There's no wrong answers here. It's just what's the most efficient way of getting down into those core root surds. The fact this has a root 2 on the bottom, I am going to go for the root 2 root 16, because that means the root 2 and root 2 are going to cancel. And you know that root 16, the square root of 16, is 4. So there we go.